So we'll begin the A2 acid topics and bases, and we'll also be looking at buffers as well. So we're first of all just going to consider the Bronsted-Lowry theory of what an acid and a base is. So an acid, as you would have come across before, is considered to be a proton donor. And by proton donor, we mean the H plus ion, which of course is just a proton if it's hydrogen 1. And a base is therefore a proton acceptor. So in a Bronsted-Lowry acid-base reaction, we are transferring a proton between an acid to a base. So here's an example. We've got hydrochloric acid and sodium hydroxide becoming sodium chloride and water. And you can see that H plus has been transferred from HCl, which is our acid, to NaOH, which is our base, to give us water. And we have nitric acid and ammonia here, forming ammonium nitrate. And again, H plus has been transferred from HNO3 to the base, ammonia, to form the ammonium ion. So if we look at this particular reaction, we have HCl as the acid and NaOH as the base. We can actually reverse it to look at how NaCl and water would react together if this reaction happened. And you'll notice that again is an acid-base reaction. Now NaCl, or the Cl minus ion, chloride ion, is now acting as a base to give me HCl, and water is the acid. So we can actually go back to the original equation and we can put together conjugate acid-base pairs, where we have the HCl and the NaCl as a acid-base conjugate pair, and the NaOH and water as a acid-base conjugate pair. And so we label them generally acid and base 1 and acid and base 2. And you can see that they differ in their formula by an H plus ion. Here we have a table of common acid-base conjugate pairs, and you can see hopefully that they do just differ in their formulae by an H plus ion. So I think it's time for a quick checkup quiz to see how you're getting on. Here are the questions, and the answers will be coming up shortly. So make a note of them. As ever, you can download these slides from my website, and then you can do them in your own time as well, or you can just pause the video now. Let's have a look at question 1, and hopefully you can see that we have methanoic acid and potassium methanoate there to form one pair, and potassium hydroxide and water to form the other pair. Question 2. We can see that HCO3 minus and CO3 2- differ in an H plus ion, so that's an acid-base pair, and the other one will of course be OH minus and H2O. So for question 3, it's probably easier to identify your two acids on each side initially. Now on the left hand side, H plus must be the acid, and on the right hand side, H2O must be the acid, because those are the two species. Well, first of all, H plus can only be an acid, and H2O is the only species with a hydrogen in on the right hand side. So those must be your two acids, which make the other two your bases, and therefore you can identify your acid-base conjugate pairs like so. Question 4. Sulfuric acid and nitric acid reacting now. We compare sulfuric acid with HSO4-, as there's a proton difference between those, and HNO3 and H2NO3+, as there's a H plus difference between those two, and so those are our pairs. And finally, question 5, we have ethanoic acid with hydrochloric acid, and again, so we've got two acids reacting together, but in this case, HCl acts as the acid and forces ethanoic acid to act as a base. So that's our first pair, and then HCl and Cl- is the second pair, like so. So in the next video, we'll look at how we measure the difference between strong and weak acids, and also how we calculate pH values.